In lesson 23-3, we're going to be talking about the law of cosines. So we're going to use the law of cosines to solve some problems today. So open up your Springboard book. We are starting on page 324, and you're going to need a scientific calculator to do those trig functions and something to write with. Okay. So let's look at this triangle here. So it said fire spotters at stations A and B noticed a fire at location C. What is the distance between station B and the fire? So we have this picture here. So they said at C there's a fire. They want to know how far away is station B from that fire. So we're trying to find this distance. Okay, so remember in these triangles we have our opposite angles. We kind of label those sides using the lowercase letters. So in this side here that we're trying to find would be like little a. Across from angle B is our side little b, and across from angle C is our side little c, lowercase c. Okay, now number one says, can we use the law of sines to solve this problem? So remember, law of sines says we can take sine A over little a and set it equal to any of the other two proportions that we know. So sine B over little b, or sine C over little c. So again, we only need two of those. Now, since we're given angle A, we probably would use sine A. Okay, and let's see. We're also trying to find side A, so we would also need little a. We could use any of these other two sides, but if I try to set this up, we would have sine of 38 over A, which again, we're trying to find. We would have to equal to that sine of, let's say if we did B over little b, 10, but I still don't know the angles for these. Same thing with angle C. I couldn't use this proportion because I don't know angle C. So that's why we have a problem. We cannot use law of sines for this problem because we need at least one more angle in order to do that. So instead, we need to use a different relationship, which is called the law of cosines. Okay. So to use the law of cosines, we have a situation like this. If you're only given two side lengths and the included angle measure, kind of like the picture here, you see how that angle measure is between the two given side lengths? That's when we need to use law of cosines. The other situation where we would need law of cosines is if we're only given the three lengths of our triangle and we don't know any of the angles on the inside. Okay. So if we're going to use law of cosines here, the rest of this kind of goes through and tells us how to prove the law of cosines, but I'm just going to show you guys how to use it to solve this problem. So if we actually wanted to find this distance, BC, okay, the distance from location B to the fire, we would use our law of cosines. Now we have three options here. So it's going to depend on the picture, what we're given, okay, to decide which kind of relationship we should use. But again, I'm going to kind of erase some of this extra stuff we don't need now. I'm trying to find the distance here, BC, from the fire. So let's look at what we know. We are trying to find A, so that has to be part of our equation. And we know the measurements for angle A. So if that's the case, we're probably going to use this top one here, because this top one's using the cosine of A, that angle. So that's the equation we're going to use here. So let me kind of just go back up here so I can see the problem. We're going to use this law. So that says A squared is equal to B squared plus C squared minus 2AB times the cosine of angle A. So let's plug in what we know. Let me relabel this because I kind of erased it. This is little b and this is little c. So we don't know A. That's kind of our unknown. So that's going to stay A squared equal to B squared is 10 squared plus C is 14. So plus 14 squared minus 2 times 10 times 14 times the cosine of 38 degrees. That's a little sloppy there. Let me rewrite this last part. Times the cosine of 38 degrees. Okay. So you could simplify this if you want, but since we're solving for A, why don't we just put it in our calculator and see what we get. So we need to do 10 squared plus 14 squared minus 2 times 10 times 14, okay, times the cosine of 38 degrees. It's 38, right? Yep. Okay. Just hit enter. Okay, and we get this value. Okay. Now remember, this is going to give us a squared. So let me just kind of round this a little bit. 75.4. So if this is a squared, how do we find just a? Well, we just have to square root that number. So in my calculator, I'm just going to hit square root. I'm going to hit second and get the answer. So this is going to take the answer from the previous problem. And there is our final answer. So let's round this, 8.7 kilometers. So how far away is station B from the fire? They're 8.7 kilometers away. Okay. So that's how you can use the law of cosines. Now again, you could have simplified this if you really want to, but if you're using a calculator, might as well let the calculator do all the order of operations for you. Just hit whatever you get, just make sure you don't forget to square root that because you want to solve for a, not a squared. Okay, so that's what this whole side of this is actually having us go through. The distance between station B and the fire we just found was 8.7. Okay, so let's do another problem. Let's jump to this page here, problem number 9. Okay, it says fire station towers are located at points A, B, and C. The distances between these towers are known. So you see how they're giving us all 3 lengths of our triangle, but we know no angles. That's another situation where law of cosines is necessary. Okay, what they want us to do here is find the measure of angle C. So this is our target here. So looking at my 3 cosine laws, I'm probably going to use this last one because I need to know what the angle for C is. So I'm going to use one that uses that angle. Okay, so again, let me label the sides here. We got little a, we got little b, and little c. So setting up this equation, which law of cosines would we use? We're going to use the c squared is equal to a squared plus b squared minus 2ab cosine of c. Because again, that's the angle I'm trying to find, so I need to use a formula that's using that angle. So let's plug and chug what we know. C squared is 11, so we have 11 squared. A squared is 5, so 5 squared plus B squared minus 2 times A times B cosine C. So there's my unknown. Okay, this one we can't really put it in the calculator like this. We do have to do some simplifying. So I blocked out that check your understanding here because you are going to need a little bit more space. So either do the work on the side here. Okay, I don't think you'll fit it in on the space they gave us. So let's simplify this a little bit. We know 11 squared is 121. Okay, 5 squared is 25, and 8 squared is 64. Okay, 2 times 5, that's 10. So times 8, that's going to give me 80. Now again, the goal is to solve for C. So I need to get this cosine C by itself. So what we're going to do is kind of simplify this down again even more. I'm going to add my like terms here. 25 and 64. That's what, 89, right? And still, the goal is to get this by itself so I can use my calculator to find that angle. Now, this might be confusing on how to kind of solve it, but what if I set it up just like a regular equation? Okay, what would you do first to solve for x? So say I took out the cosine, I put an x there. What would you do first to solve this 2-step equation? Well, hopefully you said you would subtract that 89 over. So let's see what we get here. If we have 121 minus 89, we have 32. So 32 is equal to negative 80 cosine C. Again, my goal is to get the cosine C by itself, so I can use trig. So in order to get rid of that 80 in front, I would just have to divide him out. So now we have cosine C is equal to 32 over negative 80. Now we could reduce that, but I'm going to leave it kind of how it is, and I'll show you why in a minute. So in order to find the angle C, if we're using cosine, make sure we use the inverse trig function to find that angle. Okay? So what I'm going to do here is use the inverse trig. Scoot this over so I can see the problem. So we use the inverse trig function, so inverse cosine, and I'm just going to put that fraction in there. 32 divided by negative 80. The less I have to simplify, the less room for error I'm going to make. So if I just kind of let the calculator do all the work for me, there we go. Okay, so we got the answer. Let's round here. So let's say 114 degrees. Let's round to the nearest degree. Now let's look at our picture. Angle C, that does look like an obtuse angle. So this answer does make sense. Okay, to always kind of double check your answer. If we got something like 210, we know that that can't be an angle in a triangle. So something like 114 makes sense for the problem. Okay. So it's a lot easier, in my opinion, if you're looking for a side length, because then you don't have to do all this simplifying. You can make your calculator simplify it for you. But if anytime you're trying to find a missing angle using the law of cosines, you really have to get that cosine function by itself first. So again, think of it like just like you would a regular equation. How would you isolate a variable? Do the same thing with that cosine. I'm going to erase this so we don't get confused. But I'm going to have you guys just try two problems on the bottom. So in 13A, they want you to find QR. I want you to find this missing length. So what I would do is I would relabel this triangle here. So we have side little s, side little r, and side little q. Okay. So if you're trying to find this side length, little s, you're going to have to use the cosine of big S. So just make sure, I know it's not A, B, and C, but try to use the functions that you know to kind of set up a law of cosines. Okay. So I would probably do it like this. I'll help you guys with this one. So I would probably do something like, we're finding s, so that'd be s squared. It's equal to the other two sides squared, so r squared, q squared, minus 2 rq, and then it's going to be the cosine of s. Okay, so I know it's not a, b, and c, but it's the same idea. You're just using those other two sides in your formula. So go ahead and solve this for s and see what you get. Okay, here is the work that I did. So I got that S was 7.5, aka QR is 7.5. Okay, and here's my work. So again, I set it up using the R and the Q, plugged everything in, and I just did all this in my calculator. So if you didn't get that answer, double check what you typed in. So you can plug this in first, get S squared, and then if you just square root it, you should get just S, aka QR. Okay, now letter B here, to find the measure of angle D, you're going to have to do like what we did up here. Okay, this work. So you have to set up your law of cosine, okay, and then isolate it for the cosine part of the equation. Use inverse trig to find the angle measure. Okay, so again, if I help you guys set this up, this is little d, little e, and little f. So if you're trying to find angle D, then you're probably going to use like D squared is equal to E squared plus F squared. I don't know if I need space to write all this. A little bit more space than what I'm writing here. So this is little f. So if we're solving for angle D, we'd have to do D squared is equal to E squared plus F squared minus 2EF cosine of D. Again, you're not using A, B, and C, but it's the same idea. So go ahead and set this up. Isolate it for cosine. and use inverse trig to actually find what the angle measure is for D. So go ahead and try this one. Okay, if you did it correct, you should have gotten, and we could be off by a little bit because of rounding, but I got 84.4 degrees. So let me show you my work for this one. Move this over a little bit. My work for 13B. Okay, so same setup here. So I plugged in everything I knew. I kind of squared everything out. I multiplied 2 times 11 times 19. Okay, combined up my addition here. And then to get this negative 41, I just subtracted negative 42 from both sides. Okay, if I divide that out, a negative divided by negative is positive. That's why I have positive 41 over 418. Use inverse trig and to get the angle measure. Okay, so that is the law of cosines. So again, there's 2 times where we use law of cosines. If we're only given the 3 side lengths, like in this picture, or if we're given 2 side lengths and an included angle. So anytime you can't use law of sines, you can use law of cosines.